Hello friends, today I will discuss another topic, that is common bus system with computer registers and its connective diagram. That means how to create common bus system. That means we have to design common bus system with a certain diagram with the help of computer registers and memory and its corresponding connective diagram or connectives. Okay. So, in this particular bus system, we just I took that is 8 registers, a memory and a control unit. Okay. So, this category of components or unit I consider to design a common bus, and a paths must be provided to transfer information from one register to another register between memory and registers. That means when you design for a common bus system, definitely we have to make some paths, and through that path different data transfer. That means transfer information from one register to another registers, between another register, and also between memory to registers or registers to memory. Okay. So, these kind of things we discuss or we design this common bus system. And another is whenever we will transfer our data, some register transfer data to the common bus, some register receive data, some register not receive the data from common bus, and they will only provide the data, and some registers that is receive data but not release data to the common bus. Okay, we will discuss one after one. And some output, some register giving some outputs, like a 7 register give some outputs, and memory also give some output and receive some output. Okay, that is which are those are connected to common bus and some specific output selected for the bus lines, which is determined by or determined through some binary value, which is selected by selection variables. Okay, selection variables design, that is S0, S1, S2, like this, because that selection variables is very important to that is identify particular registers or memory whenever data transfer from individual register to that common bus, or receive data from common bus to individual registers, or in between memory to register or register to memory for the different operations. So, it will be activated or detected through that is selection variables, and we take 3 selection variables like S0, S1, S2 and S2, the 3 selection variables. Since it has 3 selection variables, so we consider that is 7 registers and a memory. Okay, we will see how to design, but before that I will discuss some basic concept or basic requirements. Okay. So, next is the number. Whenever we consider the number through this particular what you call, that is selection variables. Okay, selection variable actually defined through binary numbers, but whenever the binary number we will consider, then we will consider through decimal number. Like I will explain how the binary number convert to decimal number, and how corresponding components will activate and receive the data or sending the data through common bus. Okay, the number along each output shows the decimal equivalent to the required binary selection. Suppose we will see how it is designed or how it will receive. For example, the number along with the output DR, suppose DR data register, DR means data register, number is 3, then 3 is receive, particularly 3 means data register receive data from that is common bus. Okay, and how it will identify the 3 like this 16-bit outputs here 16-bit outputs of DR are placed on the bus. When 16-bit outputs of DR, when a data register it contains actually 16-bit, and the output of 16-bit are placed on the bus. When this particular selection variable will activate, means S0 that is you see S2 S1 S0 is equal to 0 1 1. 0 1 1 means if it is a binary number, if we convert to binary number, if we convert to decimal number, its value will be 3, because 0 1 1 value is 3, and 0 1 1 is selected through that these 3 selection variable S0 S1 S2. That means S0 is 1, S1 is 1, S2 is 0. Okay, when this value is activated, then automatically number will be 3. A third particular 3 number means it is connected to this DR register, so it will activate. Activate means it will release the data from data register to common bus. Okay, so this is the basic concept. Another is I have already told that this binary form of this number is 3, and the lines from the common bus are connected to inputs of each register and the data inputs of memory. That is what happens, the 2 ways it is connected. One is each register, not all register, most of the register connected to that is common bus. It is receive the data from common bus and send the data from common bus, or the registers, each registers receive data from memory and provide the data to the memory like this. So I will show you that structure or design of that what common bus. Now see, very simple way it is mentioned. I will show you since it is a big or large circuit diagram, very difficult to draw, not difficult, but the space is less, so to draw this one is not sufficient. So I make this, collect this information or this design. So here I told that is here memory is content, that is in 1496 actually. It is 4096 actually. Okay, 4096, it is actually 4096 into 16. Memory data is 4096 into 16. How it is 4096 I have already told in one lecture, so you can see that videos how it is memory size is created based on the actually instruction format. Most of the standard instruction format having 16 bits, and from that 16 bits it created that is 4096 into 16. It is the size of that memory. And you see all of you here very simple 3 selection variables I took, that is S0 S1 S2. Okay, these 3 selection variables is important whenever we design, and this selection variable contains binary number, or it create binary number. That binary number is also making that different decimal number. Decimal number, that because this is created binary number, but binary number convert to decimal number. Each decimal number connect to individual register. For example, suppose S0 S1 S2 is 111. So 1 S01 S21 S01 S11 S21. That means 111. If all are 1, that means 7. 7, you see here number 7. 7 is connected to memory. Okay, you see 7 is connected to memory. This memory connected 7. Similarly 1 is address register. Here is address register connected to 1. Similarly PC register connected to 2. DR register connected to 3. AC register connected to 4, and DR register 3, AC register 4. IR register also connected to 5. TR register, temporary register, connected to 6, and another is the output register. Here is the input register. Output register also connected to this bus, and input register there is no connection to the this bus, and the bus contains, you see this bus contains 60 bit common bus. Okay, 16 it is a 16 you see 16 bit. Okay, 16 bit common bus. Okay, we can write also, we can common bus. That means 16 bit data can be passed through this common bus. Okay, 16 bit data. This is the structure of a that is a common bus. But how it is that is working? How it is working? What components how is working? What is the concept of that? You see here memory having that is two operation. Whenever we discuss, I have already discussed in that previous lectures how whenever data transfer, that is memory data transfer, that is two operation used for memory. One is a write operation, another is read operation. When data read from memory, that is data transfer from memory to register, any register, suppose you want to read something, then you use a read operation. Okay, when data add or enter or insert into the, or write something into the memory, then we can use a write operation. For the reason, each memory or any memory, it has two operation, one is a write operation, another is a read operation. Okay, so this is the basic concept. Another similarly, if we go through AR register, PC register, DR register, SC register, and a TR register, these 4 1 2 3 4 5. Okay, this 5 register, you see 3 that is a control, that is items, that is load. You see control items, that is load, increment, and clear. These 3 control items involved in the particular this category of register, that is address register, program counter register, data register, accumulator, that is temporary register. This register contains that kind of items. That one is a load, increment, and a clear. CLR is a clear. Okay, these 3 items are attached to this particular category of registers for different purpose. Means data load into the register, load, increment, data is increase, that is incrementer, and clear the data from the particular given register, so CLR. So like this different that is items are there, where those items that is activate whenever it is necessary as per requirement. Okay, and another is important part here you see accumulator. Whenever go through any kind of operations, addition, subtraction, or any kind of logic operation, then what happens, it all kind of operation done by this accumulator. You see data collect from here DR data register, it receive the data. Okay, receive data from input or it receive data from memory. You see register here, register data release from memory. AR register also linked to the memory. AR register address register of data. Okay, it is linked to the, you see AR register linked to the address, linked to the that is a memory unit, because address register keeps the address of data in memory. Okay, whenever any data collect from memory, it release from memory and pass to this common bus. Okay, this common bus. Suppose data collect from memory and transfer to the data register, because one example we have already discussed. Okay, like for example, very simple example we have already discussed, like suppose DR. Okay, one instruction DR receive the data from memory, where memory keeps the data through AR register. Okay, AR register means data register receive the data from memory, where address register keeps the data. Okay, that means here address register keeps the data, data transfer to the memory. Okay, and memory release the data, and whenever memory release the data to the common bus, and from common bus we see from common bus, this common bus release data to the what DR, or DR, this DR data register receive the data when memory release the data. Okay, and memory release data. That means in this case what happens, data transfer from memory to data register. Okay, so here is read operation. In this case what happens, read operation we can use read operation, read the data from memory and transfer to the data register. Okay, in this way data register connect to this and go to data register here. Okay, this is a very simple example, we can take it. Another, suppose any operation we will do, addition, subtraction, or any operation we can do, and with the help of accumulator, here is accumulator is here, this accumulator what happens, it is receive, this accumulator it operate different operations through this adder and logic. You see it connect to adder and logic. Any operation, add operation, suppose add operation, then what happens, data collect from here, send to add operation. What are the operation, what are the data they will that is operate, addition, subtraction, or anything. Then what happens, those data store in accumulator. Again suppose one operand is there, then accumulator also contains one operand or receive one operand, or itself is considered as one operand. Any suppose instruction having one operand, then SC contains one operand, another operand is involved in instruction, then that operand with a accumulator operand mix or sum of that operand calculate and again store in a accumulator. That kind of a concept also I have already discussed in previous lectures. Okay, so we can see very simple way. Suppose add x. Okay, add x means how to design, that means SC is equal to AC plus x. Okay, AC plus x, that is memory of x, memory data add with the accumulator and store in accumulator. Okay, this data means data collect from memory, here memory data collected and add with the adder through adder operation or this kind of operation here, and add with the SC. Again you see SC data again data transfer to adder, again that is transfer to SC. That means SC data plus memory data, it add the sum of this accumulator data and memory data store in SC. Okay, in this way it will that is operate of a particular category of instruction. So this is the one kind of example. Other example you can take it, doesn't matter. Okay, so every time you see suppose different operations, we load the data to the corresponding register, like address register, PC register, or DIR register, or SC register, because whenever complete that one operation, load the data particular into SC, increase the next part, next clear the previous data. So for the reason clear the data. Sometimes temporary register also keeps that some data. Okay, this is temporary TR register or temporary register. That is another concept. Okay, temporary suppose you use or store the data from memory or any other. This is the basic concept whenever we design this common bus system. I will show you. Again you see this particular input register, this input register doesn't link to the this common bus. You see there is no link, direct input register through input device, that is we will provide some data to the particular any particular this what a circuit, that is adder or logic circuit, we will provide some data. So there is no data received from common bus. We see there is no link to the this input register, only this that direct data received from input devices and sent to this operation, this any kind of function, adder or logic function. Okay, and similarly there is no link, this you see there is no link to the any common bus for this input register. Similarly output register, you see output register, what happens, this output register also receive the data from common bus. You see, this receive the data from common bus. So there is no release data from common bus. You see, there is no data released from common bus. Only receive the data, because it output to register. What happens? It this particular register receive data through output devices. Okay, only display point of view, resultant point of view, it will display the data. No, there is no data sent to register and again calculated something, no operations, only receive the data and display. For the reason, it receive data from this common bus. Another part is some clock pulse is here. Some clock is maintained by all register, or it connect to all register. You see, all register connect to clock. This clock is also it is mentioned. Okay, means at what time which operation you need to operate, which register need to activate, that will decided by this particular clock. So clock is connect to address register, you see, PC register, data register, accumulator, IR and TR and output register, but it not connect to input register, not required. Only whenever necessary, that is just to give the data from input register. No clock pulse is required for input register. Okay, so this is the basic concept of this particular common bus system. What I told, this is the basic structure of this common bus system, and you can take any kind of example to operate. That is like a addition of A plus B or something, some multiplication you can take, and you can exercise for this particular common bus, how it will calculate. For example, I told, that is one example I told, that is DR the data memory data transfer to DR. Okay, similarly you can other way we can write it like a suppose memory X, okay, transfer data R1. Okay, that means register data transfer to X. We can also write. So different operation we can do. So that kind of things is also we can do. Doesn't matter. Data transfer, content of data register transfer to here, means write here that data, very simple way. If we go through this kind of example, then what happens? Data from DR, here data transfer from DR and come to common register, common bus, and here data write into the memory for this that is expression. Okay, that data collect from data register and transfer through this bus and go to this common bus and write into the memory, if this particular category of instruction is given. Okay, so different example we can take it, doesn't matter, as your choice. You can also analyze how it is designed, how different operations can calculate. Okay, so this is the basic concept. Again, some points also we have to define. Okay, now we see here if we go through this different points, the particular register I told, that is a different part is there. Particular register whose load input is enabled receives the data from bus during next clock pulse. Whenever next clock pulse is required, then which register is required to load the data or load the inputs. Okay, and another is memory receives the contents of the bus when it is write input is activated. That means, you see, I have already told memory receive the content of the bus. So here memory receive the content of bus means write the data into the bus through write operation. Okay, so here through write operation, write input is activated. Here is a memory having two part, one is write part, another is a read part. When a write part is activated, then it will receive the data from common bus to the memory. Okay, from the memory unit. And another is memory places its 16 bits output onto the bus. Okay, and memory places, and you know that memory having here is in common bus having 16 bit capacity. So 16 bit output is used or transfer onto the bus when read the input activated by S2, S1, S0 is 1 1. That means whenever there is 7, 1 1 1 means 7. Whenever that is 7, means S2 here S2, S1, S0, is 111 means what is the value, decimal value is 7. That means whenever 7 is activated, the data transfer to the bus from memory. Memory places 16 bits, that means it is activated. When 7 is activated, then what happens, data transfer from memory, 16 bit data transfer from memory to the common bus. Okay, like this, memory places its 16 bit output into the bus when read input is activated. That means I have already told it is read items is activated or read input is activated, then automatically 16 bit data transfer to this bus, common bus. Okay, 4 register I have already told, 4 register DR SC, DR SC, IR, TR having 16 bits. You see 16 bits, it has a certain that is capacity, DR DR SC, IR, DR SC, IR and TR. These are 16 bit bits each. This 16 bits capacity. Okay, and another is 2 registers AR and PC, you see, having 12 bits. Okay, that is you see what are DR SC, DR 16 bit, SC 16 bit, IR 16 bit and TR also 16 bit. Okay, remaining bit that is AR and here AR is having 12, PC having 12 bits. Okay, these are the capacity of each individual registers, and each since they hold a memory address, although they have a memory address, but each register this AR. Okay, this AR and PC having 12 bits. Okay, and when the content of AR and PC applied to the 16 bit common bus, 4 most significant bits are set to 0. Okay, 4 most significant bits are set to 0 because it contains 12 bits, remaining 4 bits means most significant bits set to 0. Okay, because 16 bits is required, but it contains AR and PC are 12 bits, remaining 4 bits equal to 0, set to 0. And when AR and PC receive information, okay, PC receives from the bus, only 12 least significant bits are transferred to the register because it contains 12 bits. So maximum 12 bits is transferred to the registers. Okay, AR and PC. And the input register, you see, very simple, it is mentioned, the input register and the output register, both input register and output. Here input register and output register having 8 bits, very simple it is mentioned, input register and output register having 8 bit. Okay, so here we can write this is a 8 bit and another is a 8 bit, both input register and output register having 8 bit, which is very simple, just inputs of data. So communicate with 8 significant bits. Okay, 8 significant bits in the bus. Since input register and output register having 8 bit, they will provide only 8 bit data to the bus, communicate in the bus. Okay, so this is the one concern. Another is similarly, you see, input register is connected, input register is connected, that is provide information to the bus, and output register also that receive the information from bus, because you see I have already told that is input register provide the data to the provide information to the bus, input register. But here you see very simple, it is input register, actually it is provided to the operation this, and output register receive the data from the bus. Okay, receive the data from bus, what I told you. Okay, so this is the basic concept, and this is because input register receive character from an input device, which is then transferred to SC. I have already mentioned here, input provide the data to the operation and transfer to SC, and output register receive character from SC and delivers to the output devices. Okay, output register receive the data from common bus. Okay, there is no transfer from output register to any of the other register. You see, I have already told there is no data transfer from output register to any other register. Here see very simply, output register here, there is no data transfer from output register to any other register, only receive the data from common bus and display the data. And the 16 lines common bus receive information from 6 registers and a memory unit. Okay, 6 register and memory unit, because total capacity of this bus is 16-bit common bus, and bus lines connected to the input of 6 registers and the memory. Okay, 6 register and a memory, and 5 register having 3 control inputs, that is a load, increment and clear. Okay, I have already told that is the number of register having 3 control inputs, load, increment and clear. Okay, that is not all, that is a few or the 5 registers, means address register, PC register, DR register, accumulator and TR register. 1, 2, 3, 4, 5. 5 register having 3 control inputs. Okay, 5 register having 3 control inputs. So this is the basic concept regarding on that is a common bus. What I explained, this common bus, this is the basic concept. I think all of you understand this basic concept of a common bus, and it is very important to describe through different instruction, and you can take any kind of instruction set and analyze through this basic common bus system. Okay, I hope all of you understand this common bus system topic, and I hope you easily understand. If you take any kind of example, you can take it, doesn't matter, different example you can take it, analyze through this common bus. Thank you very much to watch my videos. Please subscribe my channel. Okay, thanks. If you anyone to comment on my videos, you can comment me. Okay, thanks to all.